So there is another round of Boeing rumors about the crew of the Starliner and that they're stranded because of a spacesuit debacle. Recent reports have been coming from unverified findings that the Boeing spacesuits are not compatible with the SpaceX Dragon's life support integration systems, including the audio hookups. However, we need to clear up a lot of misinformation here on your next Space Pod for Monday, August 26th, 2024. Hey everyone, this is Chad here for your roundup of space news this week. Let's jump into this discussion about the stranded Starliner crew, Sunita and Butch. Although this crew is not technically stranded, many at NASA are concerned because the Starliner data is taking too long to come up with any solid answers on what date the crew can return. Now, to address the unverified information going around the internet, that alone changes the dynamic of the discussion here as we further explain a few more holes in the argument. Second, these spacesuits were specifically designed to be upgraded and also be compatible with the means necessary to create adapters to facilitate the connections needed to other spacecraft. Now, timing will be everything here. Will an adapter be made before the Soyuz is needed? By the way, if you are new here, the Soyuz spacecraft is the Russian human-rated vehicle that ferry cosmonauts back and forth to the International Space Station. But here's the thing. There is no requirement for a spacesuit when performing re-entry procedures. Sure, the crew will be in for some mild discomfort, but the requirement for the suit is mainly for ascent because there are many more points of failure during that phase of the mission. So the point is, there is hardly any problem here as the so-called news has been making this out to be. Here at Orbital Edge, we don't jump on the herd bandwagon and copy and paste the news. We report asking the real questions. So moving on to some more space news, and this is going to be regarding the Starship upcoming IFT-5 test flight. Now, this is going to be the SN-30 with the booster, and that will demonstrate the catch maneuver. If you are new to Starship, the core booster will attempt to fly back to the launch pad, and I mean right back at the launch pad, to be grabbed by a chopstick-inspired mechanism that will catch the booster and set it on the launch pad in just a quick few moments. But before this can happen, SpaceX has too many problems to deal with, such as the heat tiles and the re-entry flaps. So far, SpaceX has not improved the heat tile mounting integrity, which means that the booster may end up landing in another random zone. The latest report places the new re-entry flaps to much better handle the plasma event that spectacularly occurred back in June with its fourth test flight. Another issue is with the new Raptor 3 engine. It is designed to be more streamlined with more thrust and also more fuel efficiency, plus better cooling. But wait a minute. It doesn't work that way, at least with this iteration of the engine. The problem with the new design is it takes all the pipes and plumbing and it places it in the inside of the engine. In theory, this would be a great idea to protect the actual plumbing from re-entry, but there's another problem that this design overlooks. The goal was to reduce the heat from re-entry without using an improvised heat shield. Unfortunately, I don't think this engine redesign is quite optimal in solving 100% of all performance categories. Although the engine looks sleek and modern, the heat generated will be much higher on the inside where they just happen to put all the components. Additionally, the outside skin of the engine still needs heat treatment. It's still a surface exposed to the screaming atmosphere as it hits the metal at 2 to 3 kilometers per second. So far, there is no data on implementing such a thing. The simple law of thermodynamics on the heat exchange or conduction would state that the heat transfer will find its way inside the engine. Most probably, the internal components are now smaller, which means less heat tolerance based on the cubic volume. Also consider this. They only did 2 short engine tests. One was 44 seconds, and then they did a 168-second firing of the Raptor 3 engine. This will not fully test the engine's full duration capability in flight, nor will it test its ability to relight without an issue during re-entry. We would have liked to see more thorough testing before the installation of all these engines for the booster. Why would SpaceX risk this? Anyone out there on the internet know why there wasn't much testing done? We are excited for the upcoming IFT-5 flight soon. However, we need to also be aware of the possible issues that could happen during this flight that no one else has been talking about. Well, in some honorable mention news, there was an explosion on a test stand by a new space startup in Europe. This happened at the rocket factory Osberg in Scotland last Monday on August 19th. This is a major setback for what was promising to be a viable private aerospace company headquartered in Germany. So we want to squeeze in just a little bit more space news. This is kind of a recent development. The Inspiration 4 crew is going to fly on the Falcon 9 on August 29th. Now this flight is supposed to be the first private spacewalk to ever occur, ever. And we are definitely excited at Orbital Edge News to see how this plays out. So with that said, we're going to package this up for now, and we hope you've learned a bit more than you did yesterday in spaceflight. I am your host, Chad, and I will see you out on the launch pad.